Alright, so in this video, we're going to look at pressure and temperature conversions. So first of all, pressure is created by gas particles colliding. So this is the force exerted on a surface by the collision of particles. So the more collisions there are, the more pressure that is created. Now if we have a vacuum, then there is no pressure, and that is because in a vacuum you have no particles. So if there's no particles to collide, there's no pressure to be created because they are not going to collide. So next we have our units of pressure. And these units of pressure are called our standard pressure. This is the pressure at which all gases are studied. And these are in your reference packet. So 1 atmosphere is our standard pressure. And that is equal to 760 millimeters of mercury, which is equal to 760 torr, which is equal to 101.3 kilopascals. So let's do some conversions. So if we have 3 atmospheres, we want to convert that to millimeters of mercury. So our unit we no longer want goes on the bottom. The unit we do want goes on the top. And we look up here, we say, oh, these two things are equal in this fashion. So we have 760 millimeters of mercury for every 1 atmosphere. So our atmospheres cancel. And let's learn millimeters of mercury. So we're going to multiply across the top and divide by the bottom, and we get 2280 millimeters of mercury. Now, like in all of our problems, we have to consider our significant figures. So this has 2 significant figures, and so we must round our answer to 2. So this is 1, 2, and we look next door. Can we round it up? Yes, and so that becomes 2300 millimeters of mercury. Alright, so next we're going to convert 1520 torr. So we have 1520 torr. We're going to convert that to kilopascals. So again, our unit we no longer want goes on the bottom. The unit we do want on the top. And those are equal by 760 torr, are equal to 101.3 kilopascals. So 101.3 kilopascals for every 760 torr. So our torr cancels, leaves us with kilopascals. Again, we multiply across the top and divide by the bottom, and we get 202.6 kilopascals. Again, we need to consider our significant figures, and so we have 3 here, and so we need 3 in our answer. So 1, 2, this is the third, and we look to the right, and we see that we'll round up, and so we get 203 kilopascals for our answer. So the relationship between temperature and pressure is a direct one, right? Just as you looked at with the Kinetic-Motor theory POGL that you did. So because as our temperature increases, right, that means our particles move more quickly. And if they're moving more quickly, they're more likely to collide with each other and with their container. And so then the pressure also increases. Please note that this says pressure. Make that correction. So the Kelvin temperature, which is the unit that we use to measure temperature in for gases, is directly proportional to the average kinetic energy of gas particles, which relates to their motion. Okay, so it's directly proportional to their motion, which means 0 Kelvin, there is no motion. Okay, now 0 Kelvin has never been obtained. The closest they've gotten is like 2 or 3 Kelvin way out into space. But they've been able to extrapolate it through data. So, in order to convert between Kelvin and Celsius, we take our Celsius temperature and we add 273. So let's say our Celsius temperature was room temperature, which is about 25 Celsius. We add 273 and we will get 298. And so the opposite would be true. If we had, say, 300 Kelvin to get to Celsius, we would subtract 273. and we would get 27 degrees Celsius. Also note there is no degree sign for Kelvin. It's not degrees Kelvin, it's just Kelvin. Okay, and so that's how we do our conversions. Oh, also, this conversion is in your reference packet as well. Okay. So we have two things in our reference packet. We have our standard pressures, and we also have our conversion for Kelvin and Celsius.